Welcome to EMILAC online tutorial. Now in this video, let us look at how to differentiate x raised to the power of 2. I'll be using two methods. Here let me say the first method, and here the second method. Alright, let's start. Y equals x raised to the power of 2. Actually, we'll be using the first principle, and by that we have that y plus change in y then equals now x plus change in x all to the power of 2. Okay, now let's make change in y the rest of the formula. So here you have change in y then equals taking y all over to the right hand side, we have x plus change in x all to the power of 2 minus y, and take note that y itself equals to what? X raised to the power of 2. Here you have change in y equals x plus change in x all to the power of 2 minus x to the power of what? 2. Now let's divide both sides by the change in x. Okay, all right. So at this point now, dy dx equals to the limit of change in y over change in x as x tends to what? 0. Okay, so at this point here we have that dy over dx then equals to the limit of this whole expression here, x plus change in all to the power of 2 minus x to the power of 2 then all over as the x tends towards 0. Now according to the law of limit, so here where you have the limit of x squared, no sorry, not x squared, x to the power of n minus a to the power of n all over x minus a, then this will give us as x tends to a, n a to the power of n minus 1. All right, now consider the numerator of this theorem correspond to the numerator of what we are solving, but the denominator it seems to be what different. So how then, what do we implement for the denominator here to give us the same pattern that will correspond to the theorem? So here we have that dy all over dx now equals limit of x plus change in x r raised to the power of 2 minus x raised to the power of 2 now all over now to this part. Now for us to get change in x, okay, and also correct it so that it will also correspond to x minus a, the pattern that agrees to the numerator here, we can now say x plus change in x minus x. You can see it's now the same pattern as with the theorem. Okay, so and to that regard now, so here we can see here that if this rule equals to this, then we can say here that dy all over dx equals, now take note that our n correspond to the power, which is 2, then our a here is our x, then our n, which is 2 minus 1. Now this will give us 2x all to the power of what? 1. All right, now which is the final answer to this question. All right, now using the second method here, let me just lift up from this end here. So here we start with change in y equals x plus change in x all to the power of 2 minus, take note our y is x to the power of 2, x to the power of 2. Now let us expand this. So by expanding, we have change in y equals x squared plus 2 x dx now plus the x square minus x raised to the power of 2. Alright, so at this point, if we were to collect like term, we will see that we have x change in y equals to x square minus x square plus 2x change in x plus change in s all raised to the power 2. So we end up having change in y equals 2x dx now plus change in x raised to the power 2. Now divide everything by both sides by dx, change in x. So all this point here we have change in x, and it also corresponds that this is 2x change in x all over the x now plus change in x square all over what? The x. Alright, so this point here we now see that dy over dx as change in x. Alright, so before we do that, we have to divide change in y over change in x. Now give us the change in x here, we eliminate here, the one here we eliminate the square, so we are left with what? 2x plus change in what? X. So now dy dx as change in x tends towards 0, so here we have that 2x, this dx becomes what? 0. So here we have that dy over dx equals what? 2x. Alright, out of these two methods, which one do you prefer? Let me know in the comment section. Alright, thank you and God bless you. Please share with others. Bye.